It's kind of wild when you think about it. Sputnik 1, that iconic satellite burning up in the atmosphere back in 58, kind of innocuous, right? Just a hunk of metal meeting its fiery end. But it was actually the start of a whole new form of pollution, something we're still grappling with today.
Yeah, it's one of those things that seems so simple on the surface,
Hmm.
but has these deeper implications that, well, we're only beginning to fully understand.
For sure. And the scale of it is mind-blowing. We've got something like 28,000 human-made objects orbiting Earth right now.
78,000.
And with thousands of satellites reaching the end of their lives each year, they're being intentionally deorbited, burning up on reentry. Add to that the projections that we'll have over 60,000 satellites up there by 2030. And it really makes you wonder, what's the atmospheric cost of all that incineration happening above us?
It's a huge question,
Mm.
and a timely one, especially for those of us who are fascinated by space exploration and the rapid advancements in satellite technology. We're so connected now, reliant on these networks for data, communication, navigation, but we need to be thinking about the environmental side of the equation too.
Exactly. And that's what we're diving into today. What are the environmental repercussions of all this space debris burning up in the atmosphere? We've got some really interesting research to dig into, some recent findings that shed light on this evolving issue. So, for everyone listening, consider this your crash course in a topic that's not getting nearly enough attention. But before we get into the nitty-gritty, let's get a handle on the scale of this. How much material are we actually talking about here? I mean, these satellites aren't exactly tiny.
No, not at all. Many of them are pretty substantial, some as big as a small car.
Wow.
And when you consider that thousands are re-entering the atmosphere every year, it adds up. Current estimates suggest we could be looking at about 3,500 tons of aerosols being released annually by 2033.
3,500 tons. That's like a constant rain of cars disintegrating into the atmosphere.
It's a significant amount.
And it's a pretty recent shift, isn't it? I mean, historically, this hasn't been a major concern compared to, say, the natural influx of meteoroid debris.
Right. Up until fairly recently, the amount of material coming from spacecraft reentry was almost negligible compared to the natural background of space dust that's always falling into Earth's atmosphere.
Yeah.
But the rapid expansion of these mega constellations of satellites, especially commercial ones, has really changed that balance.
Okay, so burning satellites equal aerosols. Now, for those of us who aren't atmospheric scientists, break it down for us. What are aerosols and why should we care about them, especially when they're way up high in the atmosphere?
You got it. Aerosols are basically tiny particles that are suspended in the air. Think way smaller than a speck of dust. And the thing about them is, they can have a surprising impact on Earth's climate. Some aerosols, especially lighter-colored ones, act like tiny mirrors, reflecting sunlight away from the Earth, which can have a cooling effect. But other aerosols, often darker ones containing stuff like soot, they absorb sunlight, and that can contribute to warming. So it's not a simple equation.
So it's not just a straightforward more pollution equals more warming situation when we talk about aerosols up in the atmosphere.
No, not at all. It really depends on the composition of the aerosol, its characteristics, and how it interacts with sunlight. And this is where the research you've brought up gets really fascinating. Scientists have found metal-containing particles in the stratosphere, things like aluminium and lithium, and the evidence points to spacecraft as the source of these particles.
Spacecraft.
Yeah. When satellites and their rocket parts burn up during re-entry, they release a whole cocktail of chemicals, including various metal oxides and nitrogen oxides.
Metal oxides. That reminds me of something. I've heard that some proposals for geoengineering, like those schemes for deliberately cooling the planet, they involve injecting aluminium into the atmosphere, right?
That's right. There have been some proposals, and they're pretty controversial, but they essentially suggest releasing tiny particles of aluminum oxide into the stratosphere. The idea is that these particles would reflect sunlight and help offset global warming.
So could these burning satellites be accidentally doing some of that, like an unintentional geoengineering experiment?
It's a really thought-provoking question, for sure. But we have to be careful about jumping to conclusions. Just because aluminum oxide can have a cooling effect doesn't mean that it's necessarily a good thing, especially when it's happening unintentionally and in an uncontrolled way. We need more data to understand exactly how much is being released, how it's distributed in the stratosphere, and what the long-term effects might be. Tinkering with the Earth's energy balance is serious business. We could see unintended consequences, like disruptions to weather patterns or regional climate shifts, things we can't predict with certainty.
It's that unintended consequences thing again, isn't it? It seems to pop up everywhere in science. We try to solve one problem and end up creating another one.
It's a recurring theme. And one of the things that jumped out at me from the research is that the levels of aluminum oxide from these satellite reentries are now approaching the levels produced naturally by meteorites. And the projections show that they'll soon surpass natural levels. So this is no longer a negligible effect. It's becoming a significant human contribution to the composition of our upper atmosphere, something we need to be tracking very closely.
Okay, so climate effects are one piece of this puzzle, but the research also digs into potential impacts on the ozone layer. That's a topic a lot of us remember from the whole CFC debate. How do these pollutants from satellites play into that picture, the ozone depletion story?
It's a crucial point. Aluminium oxide, along with other compounds released during satellite reentry, can actually act as catalysts in the breakdown of ozone. Yeah, catalysts are basically substances that speed up chemical reactions without being consumed themselves. So even relatively small amounts of these pollutants can trigger a chain reaction that destroys ozone molecules. It's kind of like a key that can unlock a bunch of doors without being used up in the process. These metal oxides can trigger the breakdown of ozone over and over again.
It sounds a bit like what happened with CFCs, and it took a global effort to phase those out, and even then, it's taken decades for the ozone layer to even start to recover.
Exactly. The Montreal Protocol, the international agreement that banned CFCs, it was a landmark achievement in environmental protection. It's estimated that a healthy ozone layer provides trillions of dollars in economic benefits. A depleted ozone layer means more harmful UV radiation reaching the Earth's surface, which leads to higher rates of skin cancer, cataracts, all sorts of problems.
Yeah.
It has a real, tangible impact on human health and well-being.
So even if the initial amounts of these pollutants from satellites seem small, because they act as catalysts, they could cause long-lasting, even subtle damage to the ozone layer, like a slow burn, a persistent problem we don't immediately notice.
Yeah, that's a good way to think about it. And the thing is, these pollutants, they can hang around in the stratosphere for a long time, potentially for decades or even centuries.
Hmm.
They're up so high that we might not see the effects right away. It's not like ground level pollution where the impacts are more immediate and visible.
Mhm.
It takes time for the effects to become measurable.
And I remember reading about a potential connection to those striking polar stratospheric clouds that are sometimes seen over places like Norway. How do those fit into the picture?
Right. Those clouds, they're actually pretty important in this whole equation. While they might be beautiful to look at, they provide surfaces where those chemical reactions that destroy ozone can happen much more efficiently. This is especially true in the presence of chlorine and bromine compounds, which are still lingering in the atmosphere from past pollution. So if you have more satellite debris up there, you potentially get more of these polar stratospheric clouds forming, and that could lead to more frequent and more severe ozone depletion events, especially over the polar regions.
It's a tough situation. We're so reliant on these vast networks of satellites for communication, navigation, weather forecasting, so many things. And right now, the most cost-effective way to dispose of them is to let them burn up in the atmosphere.
It is a bit of a dilemma, isn't it? The benefits we get from satellite technology are huge, and from a purely practical standpoint, atmospheric re-entry is the most feasible option right now. But as this research shows, there's a growing environmental trade-off that we have to acknowledge.
What are the potential solutions? I mean, I know there's been some talk about developing alternative disposal methods, things like retrieving satellites and deorbiting them to a graveyard orbit, or designing them with materials that would vaporize into less harmful substances. But those ideas seem pretty far off, don't they?
They do face challenges, both in terms of cost and technology. But it's an area of active research, and it's something we need to be investing in, especially considering the projected growth of space activity. The impact might be relatively small right now, but if we continue on this trajectory, with more and more satellites going up every year, the potential for long-term environmental consequences is there.
It's almost like a cautionary tale from history, like what happened with fossil fuels. Those emissions seemed small scale at first, but over time they've had a huge impact on the planet. We're dealing with the fallout from that now. Hopefully we can learn from those mistakes and be more proactive this time around.
Absolutely. We need to be thinking ahead, anticipating the potential consequences of our actions, especially when it comes to something as complex and interconnected as the Earth's atmosphere.
So to wrap things up, what we've learned today is that those streaks of light we see across the sky, those satellites burning up on reentry, they're more than just a dazzling spectacle. They represent a potential environmental challenge that we need to be taking seriously. The growing number of satellites up there, combined with the projected increase in space activity, means we have to think critically about the impacts of our actions. And it's not just about climate change, it's about ozone depletion, it's about the long-term health of our atmosphere, and it's about the interconnectedness of all these systems.
It really highlights how even seemingly small actions, when multiplied on a global scale, can have far-reaching consequences.
It's pretty amazing, actually, when you think about it. Something as routine as how we dispose of satellites could have such a significant impact on the delicate balance of our planet. So here's something for you, the listener, to ponder. Given our increasing reliance on satellite technology, how do we balance those benefits with the potential environmental costs? How do we move forward in a way that's both responsible and sustainable? And what kinds of innovative solutions might be on the horizon? These are questions we all need to be engaging with as we continue to explore and utilize space.
It's a conversation we need to be having now.
Absolutely. Thanks for joining us for this deep dive into the surprising environmental impacts of satellite reentry. If you found this exploration as fascinating as we did, be sure to like and subscribe so you don't miss our future dives into the cutting edge of science and technology. And keep exploring. This intersection of technology and the environment is one of the most important areas to be paying attention to in the years to come.
I agree. It's where a lot of crucial decisions will be made that will shape the future of our planet.